Well, welcome back. We continue our journey discovering the selection structure. You can pause the video at any time in order to study a slide. And as always, my printouts of the slides are available on Blackboard under the Content area. Also, all of the programs discussed are available on Blackboard under the Content tab. When you download those, you need to rename the file .java. It's always good to know where we're going. We've learned about the simple one-way if. It enabled us to take an action if a Boolean expression was true. But in this lesson, some of the general objectives are to learn about the two-way if. When we want to do something when the expression is true, and we want to do something else if the expression is false. Then we'll look at more complex if structures by including ifs within ifs, known as nested ifs. Remember when I discussed the programming structures, sequence, selection, and iteration? I said something about it is how we combine these structures to solve some very interesting and complex problems. Well, nested ifs are an example of combining a selection structure within a selection structure. We'll understand some of the common errors we'll look for when we're writing if statements. We'll introduce a couple of new math functions, random and round. We've already seen the POW used to raise a number to a power. And we'll do much of this by referring to programs examples in the book. Well, let's review a few things about the simple if. It's always good to review. The simple if's code block, set off by the braces, is executed only if the Boolean expression in parenthesis is true. The Boolean expression is constructed using those Boolean operators defined on page 72. Most of these are the same operators you learned about in a math class somewhere. Remember though, the operator to test for equality is the two equal signs, not the single equal sign. The single equal sign is the assignment operator. It is best practice, in my opinion, to enclose your code block in braces. Even though if the code block only consists of a single statement, the braces are not needed. The statements in the code block are all terminated with semicolons. And the Boolean expression, if it is false, the code in the code block is not executed, and the program resumes with the statements that follow the code block. In the slide, that is where I show more statements. Last time we ended with a little review of binary and began discussing how this guessing your birthday program is set up. Notice that each set of numbers is constructed in a very special way. All the numbers in the set require the binary bit shown in red to be 1. For example, in set 1, it's made up of all the odd numbers between 1 and 31. Because you can't have an odd number without the bit in the 2 to the 0 power being a 1. So that's the rightmost bit, also called the lower order bit, needs to be 1. The numbers in set 2 all require the 2 to the first bit to be 1, and so on and on. Notice also that the first number in each set corresponds to the decimal value of the binary representation shown in red. So we have 1, 2, 4, 8, and 16. Now for example, if your birthday is on the 19th of the month, well, binary for 19 is 10011. And we find those values in set 5 and set 2 and set 1. So we get 16 plus 2 plus 1, which gives us 19. Try it. Record the first number in the block, top left corner, and add as you find your birthday in each of the following sets. This is pseudocode for guessing your birthday. It seems to me it should be pretty straightforward. I hope you can follow it. I just kind of stepped through the first couple of iterations. Next we'll look at the listing for the programs. All right. All of these listings, as I mentioned earlier, are available on Blackboard under the content area as .jav files, and you'll need to rename those .java if you want to compile and run them. I just want to make a few comments on the Guess Birthday program. You can find the program on page 76 and 77 of your text. Okay, so the first is looking at this initialization, how the programmer declared each set of numbers that need to be displayed. Note that each of these have a /n, the escape character /n for a new line, so that the when set 1 is displayed, it'll display 1, 3, 5, 7, and then advance to a new line and display 9, 11, 13, 15, and so on. Right? So the author built these strings using the concatenation operator. Right? So set 1 is much more readable in defining it as on lines 5 through 9 than it would be if I defined it as displayed on line 10 there as a comment. Both of these declarations of set 1 are equivalent, but the first is more readable. Well, a few things to point out in the code after the declaration of the variables. Note again the use of the escape character. Line 41 goes to a new line after displaying the message. Could the programmer have used the print line method? Yes, but would need to omit then the /n, the escape character at the end of the message. Note in line 43 the use of the escape character before displaying the message. This is because if you look at the declaration for the sets, they do not end with a new line. They could, and then that /escape character new line would not be required. Finally, take a look at lines 47 and 56. They use the shorthand operators for incrementing the day. The equivalent of those statements are shown with the comments in yellow. Just simply remember that the value of day does not change until the right-hand side of the equal sign has been completely evaluated. And if the selection statement on line 46 is true, then 1 is added to the value of day, so day would be 1. And if we continue to the selection statement on line 55, if that is also true, day has not changed its value. So 2 would then be added, resulting in day being 3 when the statement completes. So just remember that the only time that the value of a variable changes is when we use an assignment operator to give it a value. Well, welcome to the two-way if statement, where the one-way if statement only allowed for the execution of a special set of instructions when the Boolean condition was true. Our two-way if statement allows for the selection of instructions to be executed when the Boolean expression is true, and a different set of instructions when the Boolean expression is false. The else keyword identifies what to do when the expression is false. Note too the use of brackets or braces for enclosing the true and false code blocks. In any case, when the appropriate code block completes execution, noted by the closing brace, program execution continues after the final code block. Well, study this code for a second. It should be pretty self-explanatory. The Boolean expression being tested is in red. Always remember, you need to enclose your Boolean expression in parentheses. All right? And then the code blocks have been highlighted with the light blue braces. So we see the true code block, the else, followed by the false code block. This slide begins to introduce a version of the nested if. The right side, the right block, is the preferred style. I've added the code block braces for clarity. Notice that each if has a matching else if. When decoding which else goes with which if, start at the bottom. The else is matched with the first if you find as you move up that hasn't been previously matched. So I've color-coded the ifs and their matching elses so that you get a better idea of what's going on. Once any of the code blocks is executed, the program execution continues with the statements following the last code block. Well, this next series of slides is going to walk us through the if statements that determine a student's grade. If our grade is 73, the first condition that is tested is for a score greater than or equal to 90. It is false, so the code will proceed to the else. Here we find another test, in which case it tests if our score is greater than or equal to 80, which is also false. So on to the next else. Finally, a condition that tests true. Our grade is greater than or equal to 70. So the code block then will be executed, and since there's only one statement in the code blocks, braces are not required. So since our score tested to be greater than 70 is true, we move on to establishing the grade as a C. So C is assigned to the variable grade. So note that as soon as the code block for assigning the grade was executed and completed, the program skipped all the remaining tests and continues execution after the last code block and the fatal one where a student would have been assigned an F. Well, this next series of slides we begin to look at a few of the common errors that can occur when writing selection statements. This first error, which is a misplaced semicolon, somewhat hard to find. It does not cause a compilation error, so your program will compile. It's not a runtime error, so the program doesn't crash. It's a logic error. So no matter what value you enter for radius, the program will compute area of a circle. So, oh well, you know, the dumb user entered a negative number, so what? They deserve to get an answer that's nonsense, right? After all, garbage in, garbage out. No, 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 no. You are a professional, and it is your responsibility to protect the user from silly mistakes. Besides, who said the value for radius was input from the keyboard? Where else could it come from? Maybe the program is getting its values from a file. Who knows how the file was prepared? Maybe your program somehow computed the value of radius as negative. The moral is you are responsible for writing code bulletproof that does not produce nonsense. So the problem here occurs because the semicolon is terminating the if statement with nothing to do. Remember, if there's only one statement, braces are not needed. The code block that remains after the semicolon there, that's in the braces, is legal syntax. And at times, in more advanced Java programming, we might use this style. A standalone code block like this can accomplish some very unique things. So, often the reason this error occurs is because we have failed to use inline block style. We've used the next line block style, which really means that if you look at the code here, that the brace is coming on the next line after the if statement. Okay, so the error here is that semicolon, if radius is greater than 0, the computer thinks it has nothing to do, and the statements following that will be executed regardless of the value of radius. Okay, the correction is easy enough. I moved the code block brace up following the test of the Boolean expression. Or did I correct it? Wait a minute. I still have that lone semicolon. Is that an error? No. It simply terminates an empty statement, a statement that does nothing. The logic is good. The radius will be tested to be greater than 0, and if it is, it will compute the area. Dumb mistake, putting that semicolon by itself, but it won't cause any logic errors or any other type of errors. So another type of error, common error, is to forget the code block braces altogether, or misplace them. Don't put them in the right place. In this case, if we study the code, if the radius is true, everything seems to work okay. I'll get an area calculated, and I'll get a message as to what my area is. However, if radius is negative, only the calculation is skipped. The program will then display the message for area. It's a good idea always to remember to use the code block braces with your Boolean statements. Well, another error. In the heat of programming, and it's always easy to forget that the Boolean operator is 2 equal signs and that the assignment operator is 1 equal sign. The statement reads logically to you and I, but Java doesn't understand it. Consequently, if you make this mistake, it should result in a syntax error with some type of message that it's expecting a Boolean. Well, finally, maybe I shouldn't say finally. I'm sure there's other errors I might think of before this video is over. But having a misplaced else statement can also cause some agony and poor logic results. The general idea here, the business rule, is that if you want to retire, you must be at least 65 years old and must have worked for the company for at least 30 years. So if line number 1 is true with a nested if, then line number 2 will be tested to see if it's true. And if it's true, then line number 3 will be executed and print out a message: you are eligible to retire. As this is written, if line number 2 is false, line number 3 will be skipped. We'll hit the else statement, and line number 4 will be executed, which says that you're too young to retire. The error is caused because the else is being paired with the wrong if. Remember, if we want to know which if is paired with the else. We start at the bottom and work up, and we see that the else is paired with the years of service and not with the test for age. So how do we correct this error? Well, by adding the code block braces in red to encapsulate lines 2 and 3, I have now correctly paired the else statement with line 1. But wait, didn't I say that the else statement should be paired with the first if? Well, yes, I did, but if we reading from the bottom to the top, I have a red block brace that terminates that if completely, and so it won't be looking for an else statement. So by enclosing that second if, all right, in the code block braces, we ended up pairing the else with the right if, and now if the employee is less than 65 years of age, we'll get the right message. Well, another thing to consider with selection statements is being somewhat redundant and showing a lack of an understanding of how the Boolean expressions work. The code in box A on the left there is redundant. If I want to interpret how that would be read by the computer, it would test for age greater than 21, and then it would be testing for either true equals true or false equals true, because age greater than 21 will evaluate to true or false. So don't be redundant in that testing. All right? The Boolean operators result in a Boolean value, either true or false. So block B is better style. It shows that you understand how to use the Boolean operators correctly. Okay, this is the second little math tutorial program for first graders, kind of teaching them how to do subtraction. The first thing to notice new in the program is that it uses the random method of the math class, which is built in, to generate a random number. Now, random generates a number between 0 and 1 as a decimal. To get an integer that the first graders are going to understand, we need an integer between 0 and 9. And so we multiply this random number by 10 and then convert it to an integer by using the cast operator to int for an integer. And since first graders don't understand negative numbers, it's necessary for the program to test to see if we need to swap the values in number 1 and number 2. For more explanation of the program, watch the next video regarding this program. Well, the next program of interest is the Body Mass Index program. Body Mass Index is computed from a person's weight and height. It must be converted to kilograms and meters, and it's an indication of your overall health. The program is on pages 84 and 85, and the program is really a good example of the use of if and else if. Pay attention to lines 15 and 16, and where the program declares constants to be used in the program. Basically, the problem presented is that after computing the BMI value, you need to interpret the results based on this table. The use of if and else if do a nice job. The programmer only needs to test for the BMI being less than or equal to the values in the right-hand column. Other than that, the program is pretty straightforward. Please watch the author's video further explaining his implementation. Well, Being though this is the beginning of a new year, everybody is interested in preparing their tax returns, so they might get some money back from Uncle Sam. The easy way to compute taxes, federal income taxes, is to use a table that is based on your filing status and the amount of income you've earned. So across the top of this table, there are 4 filing statuses: single, married filing jointly, married filing separately, and head of household. And down the table columns are ranges that define the tax rate given in the far left column. Okay, because taxes aren't so simple, it takes a little bit of explanation on how taxes are computed. So suppose that you're single and you earn $35,000. Well, you pay tax on the first $8,350. Then you pay an additional tax on the amount greater than $8,350 but less than $33,950, and then you pay a little bit more tax on the amount greater than $33,950. So to begin, we'll start with our $8,350. We'll compute the tax on that at 10%. That'll be $835. Now we subtract $8,350 from $33,950 on line 2. That's the maximum amount. We've already paid tax on the $8,350. So our obligation is to compute tax on the remainder, which is $25,600. And we only need to be taxed at 25% of that amount. And that gives us $3,840. And finally, my earnings of $35,000 fall between that range on line 3, and but since I've already paid tax on the first, or computed my tax on the first $33,950, I only have to pay or compute tax on the remainder, what's left over after that $33,950, and that's $1,050, which would be taxed at 25%. So my tax, that obligation that is due, is $835 from the first $8,350, $3,840 for that amount between on line 2, which is a total of $25,600, and then $262 for the $1,050 that remains. So my total tax is the $835 plus the $3840 plus the $262.50 that is added. So my tax obligation is $4,937.50. Oh my, oh my, oh my, where do we start? Well, we always start with developing pseudocode. And this tax program is a very good example of being able to use incremental development and incremental testing. So you see this first part of the pseudocode. It is enough to get started developing a program. We don't have to, at this point, concern ourselves in the implementation with computing the tax. We could, in our programming, simply replace the compute tax line with a message displaying what status was selected, and could then run that program, test that we are getting to the right area of the program based on status. So once we've developed and tested that our program is going to the right areas based on status, we then could develop the pseudocode for computing the taxes simply for the single status. And you can see there is a small amount of the single pseudocode there, right? Add this code to your program and test it, right? Don't try to test computing the taxes for all statuses at the same time. You'll have too many mistakes. You won't understand where your errors are. Test status. Test each increment of income and compute those things manually. All right. Once we've understood and have assured ourselves that we are computing taxes correctly for the single status, then we can move on to the next status. And basically in the development then, it's a copy and paste job, and then changing the number ranges and test that, and then move on to the next status. Okay? When you finally get ready to display the taxes due, there is one more step. So just before we display the tax due, the last thing we need to do is to understand how to round the tax due. Uncle Sam wants every last penny. So the method that we've been using with converting a decimal number to 2 decimal places does not do rounding. So the next slide we'll take a look at some code that will do the rounding. So I think the best way to explain how to do rounding is to use an example. All right, so we'll begin with a value that is 13.4675. And if our rounding works to 2 decimals, we want to come up with a result of 13.47. One of the things to understand is that the round method of the math class rounds only to a value to the nearest integer. So if I simply tried to round my value as it is, I would end up with 13. So kind of like we did with converting to 2 decimals, all right? It's necessary to preserve those 2 decimal places. I multiply by 100. All right. Now I can round that number. I have 1346.75 after I multiplied by 100. Applying the round will yield a number 1347 as an integer. Now we need to divide by 100 as a double to finally get back to 13.47. If we simply used 100, remember that's an integer, and a math round returns an integer, and so an integer divided by an integer will yield only 13. I'll lose my decimals. So very similar to how we preserve 2 decimals with the multiplication by 100 and then the division by 100. But now we are using the math round method to get our rounding. Well, that's it. I'm sure that I probably caused some questions. Be sure to bring those up in class. Kind of our little bean man there is scratching his head, wondering if he'll ever remember all this stuff.